Well, hello everyone, and welcome to building your own MCP server. My name is Stuart. I work as a software engineer at Solclasteria, and I'm also a Microsoft Foundry and Azure MVP. Now, before we start looking at our Model Context Protocol servers, let's look at the protocol itself shortly. And the short summary of it is it's a protocol that enables us to connect our AI agents or AI applications to these external systems. And these systems can be pretty much anything. They can be apps, they can be SaaS products, entire databases, APIs. The list is virtually endless. And the protocol sits in the middle, and it's the thing that we are connecting through. And the things that we're actually connecting to is what we're here for today. And these are the Model Context Protocol, or MCP, servers. And these servers, they consist of multiple components. And today we're going to take a look at three of them. We're going to take a look at tools which enable our AI models to perform actions or carry out tasks. We'll be taking a look at prompts, which are reusable templates that demonstrate or showcase to the user what the MCP server is capable of or how to interact with the MCP server. And we're going to take a look at resources which provide read-only access to information that can enhance the context that the AI model is operating in. And that's enough of PowerPoint, so let's head over to VS Code for some actual demos. Now, before we actually start building, let me tell you about what we'll be building. Because we're going to build an MCP server for the employees of everyone's favorite fictional paper sales company, Dunder Mifflin. Our MCP servers will allow employees to search for information about their colleagues, about some orders, also about any rules or ways of working that they have within Dunder Mifflin. And we'll be taking a look at all three of those components that we just talked about. Now, before we actually start building, we need to add a NuGet package to our project, specifically the Model Context Protocol NuGet package. This is the official Model Context Protocol SDK, and it's one of the easiest ways to get started with building your own MCP server. Now, this SDK will give us access to some methods and extension methods in our program.cs. So over here, we just add an MCP server, and that's really all we need to get up and running. We've already turned our application into an MCP server. Now, the first extension method you see over here, the with standard IO server transport, tells us that we're working with a local MCP server. It turns out MCP servers come in two flavors. We have local ones, which run on your own machine, and we have remote MCP servers, which run somewhere else, and you just connect to those servers. Now, the standard IO transport is a local communications channel, so this tells us we're working with a local MCP server. If we were working with a remote MCP server, we would use with HTTP transport. So just like anything on the internet that we're connecting to through HTTP, we also connect through HTTP to a remote MCP server. Now, the other extension methods with tools, with prompts, and with resources from assembly, those are the three components we just talked about. And the from assembly part tells us that these extension methods will use reflection to search for certain attributes in our code to expose those components through the MCP server. So let's take a look at that right now. Starting with tools, we open up our employees tool over here. And the first thing we see is an MCP server tool type attribute on our class. So this already tells us, as well as the extension method, this is a place where MCP server tools live. And on the method itself, we set an MCP server tool attribute, and that tells the extension method to expose this method as an MCP server tool through the server we're building. Now, we give the tool a name as well as a description. And this description is actually very important because this is what the large language model is going to use in order to determine whether it should use the tool or not. It's going to take your prompt and it's going to compare it to this description. So if I were to prompt, hey, give me a list of Dunder Mifflin products, it's going to take my prompt, compare it to the description, which is all about Dunder Mifflin employees, and hopefully it's going to find that it should not use this tool for this prompt. Now, if I were to prompt about Dunder Mifflin employees or people who work at Dunder Mifflin, again, it's going to take that prompt, it's going to compare it to this description, and it will probably find that it should use this prompt or this tool in this case. Now, the other thing that we do over here with this tool is we set an optional limit of the number of employees to return. So what we actually do is we just get all employee information from a database. If we set a limit, so return 5 employees, for instance, we just take the first 5 employees over here and we return them to the user. If we don't set a limit, we just return everything to the user. So that's our tool set up. Let's now take a look at the prompts. And again, on the class, we set an MCP server prompt type attribute telling the extension method, hey, this is a place where prompts live. And on the method itself, we set an MCP server prompt. Again, we give it a description. And this one isn't really for large language models. This one is aimed at humans, at the users of the MCP server. Of course, that doesn't mean it's any less important, but it does kind of change your approach as to how to describe something. And as I said, it's not any less important, and it doesn't mean that you should be less descriptive. You're just describing it for a different audience. And what we do over here in the prompt is we return a string to the user with a limit that will be specified by the user. So pretty much the exact same thing as we saw with the employees tool. But in this case, we always specify that limit. And then last, but certainly not least, let's take a look at resources. And hopefully we kind of know the drill by now. On the class, we have an MCP server resource type attribute. And on the method itself, we have an MCP server resource attribute. We specify what kind of data we're working with. Again, we give it a name and a description, which in this case, the same as with prompts, it's aimed at humans and users of the MCP server. And what we do is we expose the contents of the Dunder Mifflin employee handbook to the model. So it turns out Dunder Mifflin has an employee handbook that's never been published to the internet. So it isn't part of any large language model's training data. So if we were to ask any random model about Dunder Mifflin's employee handbook, it would either ask us to search through our files, search the internet, or it would hallucinate something and just make it up. But by exposing the contents of the handbook to the model, it can now answer any questions that we ask it about this handbook. So we built our 3 components by now. All we need to do is configure our MCP server so that we can actually use it. And we do that by creating an mcp.json in the .vs code folder in your workspace. And we configure the MCP server like this. At the top, we give it a name, in this case, Dunder Mifflin MCP local. We specify the type and we see the standard IO again. So this is a local MCP server. And because it's local, we just get to run a command. And in this case, we just run a .NET command and we pass in some arguments, mainly run this project at this location and don't build before running, just run it straight away. If we were using a remote MCP server, instead of standard IO over here, we would specify HTTP. And because it's running remotely, we don't get to have a say as to how anything is executed over there. We don't get to run a command or pass in any arguments. So if we specified HTTP, we would simply, instead of commands and arguments, specify an HTTP endpoint or a URL for the location of the remote server to connect to. But let me start the local server over here. We can already see it's running. It's not the biggest server in the world, and so it starts pretty fast. And let's now open up GitHub Copilot over here. Now I'm just straight away going to ask it, give me a list of Dunder Mifflin employees. And it's going to take a second to reason over my prompt. It's optimizing the tool selection, and hopefully it's going to get back to me. There we go. It says, hey, I found this get employees tool for you in this Dunder Mifflin MCP local MCP server. It returns that description that we set in the beginning. And it's also saying, hey, the limit is null because we didn't specify a limit. We just said, give me a list of Dunder Mifflin employees. And basically what this is saying, or asking actually, is it okay for me to run it? It's also warning me that some MCP servers might be malicious, but in this case, I know which MCP server it is. So I'm just going to say, yeah, it's okay. Just run it this one time. And it's actually already done running. So let me open up the actual tool call. Again, we see the limit is null, so we didn't specify a limit. So it's just getting all employees. And over here, we see that it actually was returned a massive JSON object with all the employee information in there. And what it was doing while we were talking about that was it was just reading through that content just to see, hey, what is data that I want to present to the user? And eventually, it just gives me a list of all Dunder Mifflin employees that were in the database, and it just presents a list to me of all those employees. So our tool seems to be working pretty well. So let's start a new conversation and let's try out our prompt. Now we can get to prompts by simply typing a slash, which will give us a list of, well, prompts and slash commands. And if you just keep typing, you'll filter through that list. So I'm going to type Dunder. So here we see our Dunder Mifflin MCP local example prompt. Now, as soon as I hit enter, watch what happens in the middle of the screen. We get this little pop-up asking us to specify an employee limit. Now I'm just going to put in 5 and watch what happens now in the bottom right chat window. As soon as I hit enter again, we get that string that we specified earlier. We get that prompt filled in with that limit that we just specified being a user. Now, if we send this again, it's going to analyze the prompt. Hopefully it's going to find the tool that we just ran. There we go. Now I'm not going to run it again because it will just give the same output as before, but only with 5 employees. But I do want to show you that it did now analyze my prompt and it found that limit of 5 employees to return. So that all seems to work pretty well as well. Now, last but not least, let's take a look at resources. And again, I want to reiterate the large language models, no matter which one we pick for GitHub Copilot, they don't know anything about the Dunder Mifflin employee handbook. So if I were to ask any question about it right now, it would just make something up. It would search the internet, search through our files. It would ask to search through our files, but it doesn't really know about the handbook. But we can add resources to enhance that context that the model is operating in by clicking this plus icon over here. And again, we get a little pop-up with all kinds of attachments that we can add. Now we're interested in MCP resources, and I'm just going to select that employee handbook. So you can see now that it added the employee handbook to the prompt that we're about to send. And I'm just going to ask it, are there any values in the employee handbook? And again, it's reasoning over that prompt. It's just searching through its context that it has now. And it says, yes, the handbook explicitly lists these values: integrity, humor, respect, and commitment. And just to show you that we're not faking this, I have the handbook over here. It's just a simple markdown file. We scroll down a little bit. Over here, we see values. And again, integrity, humor, respect, and commitment. Now, everything seems to be working well with our MCP server, but it's all running locally on my machine. And I don't want anyone that wants to use this MCP server to have to connect to my machine. So what we could do is we could make the MCP server a remote MCP server. But that would still require the employees of Dunder Mifflin to bring their own agent, whether it's GitHub Copilot or ChatGPT or whatever AI assistant they want to use. And instead, we can also provide them with an agent that's already connected to the remote MCP server. And that is where Microsoft Foundry comes in. Now, Microsoft Foundry is the one-stop shop for everything agentic AI. You can deploy instances or your own instances of large language models. You can deploy your agents. You can connect your agents to any tools that you have or any Microsoft or other third-party tools. You can connect them to your own knowledge bases. You can test and evaluate your agents, and eventually you can publish them wherever you want to host your agents so that your users can actually use it. Now, what I've done already is I've deployed an agent already and I've already defined the Dunder Mifflin remote MCP server. Now we can just go to the Dunder Mifflin agent over here, and you'll see on the left here that there are no tools connected yet. So we can just add a tool over here. Now I've recently used the Dunder Mifflin MCP server, so I can just simply add it from here. But you can also add any other tools you have lying around or any first or third-party tools by browsing all tools, and you just get an entire catalog of everything that is available or anything that you really want to add. I'm just going to select the Dunder Mifflin MCP server, and I'm just going to prompt it for the same thing we did earlier. Just give me a list of Dunder Mifflin employees. Now this is going to take a little while because it has to connect to the MCP server that is hosted in Azure. But eventually it will get back to us with the same kind of challenge that we saw earlier, the saying, hey, am I allowed to actually run this? Is this safe? Is this something that you recognize? Now, the funny thing is, in this case, it did specify a limit for some reason, even though I didn't explicitly state, just give me 10 employees. But it did find a limit. So maybe my prompt should have been something like, hey, give me a list of all Dunder Mifflin employees. Well, yeah, large language models are going to do what they do best. They're going to generate and sometimes hallucinate something. But here we get the same challenge. It's basically telling us, hey, I found this get employees tool. I'm going to call it with this limit that was set. Is it okay for me to call it? And I'm just going to approve it once. Same thing. And functionally, it's the same MCP server. But instead of running on my machine over here, it's running somewhere in Azure, somewhere in the cloud. It's all running maybe a little bit slower right now. I'm using some lightweight plans and some lightweight services. But there we go. We got 10 employees back according to the limit that was set. And because we got some fewer employees, we got some more information per employee. So we got their job title, their status, whether they're still working with Dunder Mifflin or whether they've already moved on to a different job. But let's try again. Let's see. Well, let's first start a new conversation. Give me a list of all Dunder Mifflin employees. Let's see whether that makes a difference. It does. Now it says, hey, there's no limit. So again, I'm going to approve it, and it's going to run again. And it's going to give me the same, there we go, the same 54, including their job title, which it didn't do when running locally, funny enough. But it returned the same 54 employees as before. So our MCP server, also the remote version, seems to be working pretty well. We might want to do some more extensive testing and evaluating its performance and whether its responses are actually grounded in the data that was provided to it. But eventually, we want to publish it to our users, whether it's through Teams or Microsoft Copilot or any other AI assistant that supports agents, which is all possible from Foundry. Now, with that, I told you all for now there is to tell about getting started with building your own MCP server. So just a quick recap, get the Model Context Protocol SDK. It's one of the easiest ways to get started with building your own MCP server. Make sure that you pick the correct component for whatever you're trying to build, whether you're trying to get a model to perform some action or carry out a task. Pick a tool if you want to enhance its context, pick a resource, and if you want to showcase to the user what your server is capable of or how to interact with it, create a prompt. Thank you so much for spending some time with me. This QR code will take you to a repository where you'll find resources, including all the code that I showed. Thank you so much for listening and enjoy the rest of your day.